All right, give me 1 second. Adjust my computer. Okay. Why are you? Hold on. Okay. So I'm going to be working through this worksheet on curvature and normal vectors. This one is mostly just computational, so I don't think this one's too important, but still I've had requests to do these, so I'm going to go and do that. Okay, so number one, find the unit tangent, unit normal, and curvature of this curve, which is R. Oh, no, I don't want purple. I want blue. R of t equals root 2t e to the t e to the negative t. Okay. And then t is a real number, so we don't have to worry about any domain stuff. Okay, so again, the first step to finding our unit normal and tangent vectors is we need to find r prime of t. So that will be equal to root 2 e to the t negative e to the negative t, just taking those derivatives. Make sure we don't make any mistakes there with like chain ruler stuff. And then all we have to do is remember our formulas for the tangent vector, which is, oh, nope, not that. R prime of t divided by the length of r prime of t. The normal vector, which is t prime of t divided by the length of t prime of t. And then curvature, which is equal to the length of t prime of t. Oh, that's not. Divided by the length of r prime of t. The reason I'm using this formula instead of the length of r prime cross r double prime divided by the length of r prime cubed. The reason I'm not using this formula is because I'm already going to compute t prime of t, and so I don't really want to have to compute this cross product because I'll already have t prime of t from up here. Okay, so let's do that. First, to get t of t, I need to find the length of r prime of t. So that is going to equal square root of this thing squared, which is 2, plus this thing squared, which is e to the 2t. Remember, a to the b to the c is equal to a to the bc. And so here a is e, b is t, and c is 2. Okay. And then this one's also this one's e to the negative 2t. This negative sign goes away because we squared it, but this negative sign doesn't go away because it's not, this isn't the thing being squared. This is the thing being squared, this whole thing. If you want, another way to think of it is you can factor out this negative since it's being multiplied. So this would be, well, that's not a good way to do it. You would get negative e to the negative t squared. So that would be negative e to the negative t times negative e to the negative t. And so these two negative signs cancel out, but these two don't because they're in an exponent. So that's why this negative sign goes away, but this one stays. Okay. And then I gave this formula in Studio. I don't really like that you're not given this formula, but this is equal to e to the t plus e to the negative t. If you want to check that, you can square this and see that you get that, but I don't think you can do that if you want real quick. You can just FOIL it and you will get this if you try that. I think it's stupid that they don't give you this formula. Okay, so we did that, and so now t of t is equal to 1 over e to the t plus e to the negative t times r prime of t. So that's root 2 e to the t negative e to the negative t. Okay. So we found this one, and I'm just going to highlight the things that we have so far. We have this, we have this, we don't have this, we don't have this, we don't have this, but we do have this. So evidently the only things we left are t prime of t and the length of t prime of t, which will be a little bit annoying to do, but let's get started with that. I'm trying to figure out if there's going to be a better way to do this. I don't think so. This one is just going to be really ugly and we'll have to deal with it. I think one thing that might make it that won't help much. Maybe. No, actually it won't. Well, yeah, I'm gonna... no, that won't really help much. Okay, let's just compute the derivative. For this, I'm going to use the product rule. The product rule works even for vectors. So like r dot y prime is equal to r prime dot y plus r dot y prime, and similar formulas for all different types of vectors. The product rule still works for vectors, is my point. So we can use the product rule. So it'll be this times the derivative of that, which is 0 e to the t e to the negative t, because now there's two negative signs, so they cancel out. Don't forget to do the chain rule. Plus, and this one's the harder term, we have to take the derivative of this. So I'm going to do that on the side. Okay, so this is equal to e to the t plus e to the negative t to the negative 1 prime. And so I'm going to do the chain rule on this. My inside function is x to the negative 1. Or sorry, my outside function is x to the negative 1. And my inside function is e to the t plus e to the negative t. The reason I'm splitting it up like this is because I know how to take the derivative of each of these individually. Okay, so that'll be... the derivative of this is negative x to the negative 2. So this will be negative e to the t plus e to the negative t to the negative 2. And then the derivative of this is e to the t minus e to the negative t. So it'll be times e to the t minus e to the negative t. And I don't think there's a way to simplify that. So I'm going to put that in here. This would be, instead of plus, it's minus because of that negative sign. And we'll have, what is that? E to the t plus e to the negative t squared, e to the t minus e to the negative t. And then don't forget this part. Okay, so that's my product rule. I just did first times derivative of the second, which is this term, plus second times derivative of the first, which is this term. So it's a little bit ugly, but we can do it. Okay, so now we have this, and we're almost done. Now to get these last two numbers, we need the length of t prime. To do that, I'm going to combine these into one term because it will make it easier. And so to do that, I need to get a common denominator between these two fractions. So that'll be e to the t minus e to the negative t over, plus e to the t plus e to the negative t squared, 0 e to the t e to the negative t minus e to the t minus e to the negative t over e to the t plus e to the negative t squared times root 2 e to the t e to the negative, no, that's not right, negative e to the negative t. Okay. And so now what I can do is I can add just the numerators and keep the denominator, because that is how fractions work. And I'll do it component by component. So let's see, that is going to be this one. This first one is, I'm doing this one and this one. This first one's 0, so we'll just have negative e to the t minus e to the negative t times root 2 over e to the t plus e to the negative t squared. Okay, now I'm going to do the second two terms. So this one, e to the t times this is e to the 2t plus 1, and then e to the t times this, keeping into account the minus sign, that'll be negative e to the 2t plus 1 all over e to the t plus e to the negative t squared. Okay, and then I'll do a similar, I'm running out of colors, so that one's my purple. And then let's just make this last one brown. So that will be this times this. That will be 1 plus e to the negative 2t. And this times this, keeping into account our negative signs, is going to be plus 1. And then here we have 3 negative signs. That's minus e to the negative 2t over e to the t plus e to the negative t squared. So that's the brown and the brown to get this guy. Change you back to red. I like red. Okay, and now the reason I did this is because you can factor out these denominators. And then this becomes root 2 times, and then I'll use that negative sign to flip the order of these two. So that's e to the negative t minus e to the t. Here, these two cancel out, the e to the 2t and negative e to the 2t. So that'll just be 2, and then the same thing this last term, that's just 2. Okay. So why did I do all this? Because there's this cool fact that the length of some constant times a vector is equal to the constant times the length of the vector. And so when I'm finding the length of t prime of t, I can just factor out this constant, and that makes the arithmetic a lot easier. So that will be 1 over e to the t plus e to the negative t squared times the square root of, I'm going to do these two first. It's going to be 4 plus 4. And this term is going to be 2 times, and this thing squared is e to the negative 2t plus e to the 2t minus 2. All right, so we're almost done. And actually, we could be done right now. I'm pretty sure this simplifies, though, so I'm going to simplify it a little bit. 4 plus 4 is 16 minus 4, so that'll just be 4 plus 2 e to the negative 2t plus 2 e to the 2t. And yeah, that does simplify, although it's not quite obvious why. This thing here, by the way, you wouldn't be expected to do this on a quiz or test. This thing here, I can factor out a root 2, and then I get the same thing that I had earlier, which is, I'll write it out, but then I'll replace it with what it actually is. 2 plus e to the negative 2t plus e to the 2t. But earlier I showed you that that's just e to the t plus e to the negative t. And so after everything, this is equal to root 2 over e to the t plus e to the negative t, which simplifies a lot more than you'd think it would. Okay. And so now I have these two. So I have everything I need to get my answers. I already found t of t, which is right here. To get n of t, I just have to divide these two. So that's t prime of t, which was this, divided by this. So n of t is equal to this here, and then divide by this is the same as multiplying by the reciprocal, so that's e to the t plus e to the negative t over root 2 times 1 over e to the t plus e to the negative t squared. And then times my actual vector from above. So that's root 2 e to the negative t minus e to the t to 2. There's an easy way to do this in terms of hyperbolic sine and cosine, isn't there? I don't think most people know that, though. Whatever. So this is 1 over e to the t plus e to the negative t. I'm putting the square root of 2 inside. So that is e to the negative t minus e to the t. 2 over... 2 over root 2 is equal to just root 2. Root 2. Okay, and that is our final answer for n of t. And then finally for kappa, that again, remember, is the length of t prime of t divided by the length of r prime of t. The length of t prime of t was root 2 over e to the t plus e to the negative t divided by the length of r prime of t was e to the t plus e to the negative t. And isn't that crazy? That's just root 2. Which I think is really interesting. All of that annoying arithmetic, and it just ends up being root 2. Okay. That one, I don't think you would really have to... I'll circle those. I don't think you'd have to do that one on like a quiz or exam or anything, because it's just way too much algebra. And there are ways to simplify it, but they're sort of too complicated for us to actually ask you to do them. Oh wait, I messed that up. Because here... Yeah, sorry. I multiplied them, I didn't divide them. That makes more sense. Remember when you divide, you have to multiply by the reciprocal. That makes more sense. Okay. I was talking because I was stalling while I was trying to figure out where my mistake was, because that did not look right. So that'll be root 2 over e to the t plus e to the negative t squared. The reason I knew that wasn't right is because the only curve with a constant curvature is a circle, and this obviously is not a circle. Okay, so that's this problem. I wouldn't worry much about having to do this. You wouldn't have to do this in a test, exam, quiz, or even really in homework. It's just way too much algebra. So let's move on to number 2. This one is also annoying, but just a little bit less annoying. I'll just take a screenshot of that real quick and then put it down here. We want to find Tn and kappa for this space curve. Okay, so again, we just need to use the same formulas that we used up here. So this process will always start by finding r prime of t. So let's do that. Here it's going to be... Oh, this is going to be ugly, isn't it? Okay. Derivative of that is negative sine of t. The derivative of this, we'll use the product rule. So that's going to be t cosine of... Oh, wait, sorry. Plus t cosine of t. Plus sine of t. That's just the product rule. First times derivative of the second plus second times derivative of the first. Okay. This next one is going to be derivative of sine is cosine, and then we'll do the product rule again to get t sine t. Oh my god, I keep writing comma. It's plus minus cosine of t. And then the last one, the derivative of 3 is just 0. Okay. These sines and cosines cancel out, so this is t cosine of t, t sine of t, 0. Okay, and then I'm just going to factor out that t because it'll make things easier later. Whenever I see something in all of my terms for my vectors here, it's always a good choice to factor them out. Okay, so we did that. Now we need to do the length of r prime of t. Okay, so again, this is a constant out in front. We can factor that out of the length. So it'll be t times the square root of cosine squared t plus sine squared t plus 0. But this is one of our identities that we need to know. I'll just write it on the side in case you forgot. I'll write it up here. Cosine squared t plus sine squared t is equal to 1. This is one of the most important identities in this class. We'll use it a lot. And so this here is just equal to 1. So our length is just equal to t. Okay? And so remember, to get the tangent vector, we do the velocity vector divided by the length of that vector. And so this t, these two t's will just end up canceling out. And that'll be cosine of t, sine of t, 0. Nice. Okay. So now let's find the normal vector. This one's going to be easy, don't worry. Remember, this is equal to t prime of t divided by the length of t prime of t prime. There's a glitch with this note taking up. Oh, no, not there. Where sometimes if I switch to the eraser, then back to the pen, it'll still select the eraser for like 1 or 2 frames. So I don't know. Anyway. So we need to find t prime of t. I'll do that right here. It's relatively straightforward. Negative sine of t, cosine of t, 0. Okay. And so let's do that. I'm going to find the length of this also real quick. Again, it's going to be square root. This first number squared is sine squared t. The second number squared is cosine squared t. And then 0 squared is just 0. And so the length of that vector is 1, because sine squared plus cosine squared, again, is 1. Remember, up here, our big important formula. Okay. And so the length of t prime of t is 1. I can just ignore that. This will be just t prime. Okay. And so now I can find kappa, which is my curvature. Again, this is the length of t prime of t divided by the length of r prime of t. And again, the reason I like using this formula is I've already found all these numbers, and so I just get to plug them in. So let's see, t prime of t, the length of that we found earlier was 1. We did that over here. And then the length of r prime of, oh no, not red, blue. Length of r prime of t, we did that way up here. And that length was t. So it's just 1 over t, which is a very nice curvature. Okay, so that one's a little bit simpler. This is closer to something you'd be expected to do on an exam, although still it's a little bit complicated because if you don't realize a few simplifications, it'll get really ugly. But it's possible you'd be asked this. It would just be a mean question. Okay. Number 3, this one's going to be ugly, but I'll do it for completeness. Okay. Ooh, okay, actually there is an easy way to do this. So, okay. Let's start by finding the tangent vector. So to do that, we need do we need the curvature? We don't need the curvature for this one. Did we need the curvature for the last one? Yes, we did. Okay, but not for this one. So let's see. R prime of t, that's always our first step, is equal to derivative of t is 1. Derivative of this guy is t squared. Okay. And t is not 0. So that was easy. Let's find t of t. Okay, so that'll be the length of r prime of t. So that is square root of 1 plus this squared is t to the 4th. Oh wait, sorry, that was the length of r prime of t. That's our second step. My bad. I read the wrong symbol. This is square root of 1 squared is 1, t squared is t to the 4th. Okay. And unfortunately, there's not a good way to simplify this, and so we'll just get that t of t, remember we divide these two, be 1 over square root of 1 plus t to the fourth times 1 comma t squared. Okay. So now we need to find the normal vector. And normally we would have to do that an ugly derivative of the tangent vector, but there's actually a easier way to do this. So to see this, I'm going to draw a picture. Here's my picture. Okay. So let's see. This is the curve that's parameterized. If you'll look at the question, x is equal to t and y is equal to 1/3 t cubed. And so this is the obvious parameterization that I talked about in the online studio, where we can just substitute x for t so that y is equal to 1/3 x cubed. And so it's a cubic, which is right here. Okay, so we found the tangent vectors. The thing about the normal vectors is that they're always going to be perpendicular. If this, actually I'll make it a different color. If this is my tangent vector, the normal vector is always going to point perpendicular to that vector, and it'll point inward in the direction that I'm curving. And there's only one possible normal vector, like it has to be unique. There's two possible like perpendicular vectors, those two are perpendicular, but we want to choose this one that points inward. There's actually a shortcut in 2 dimensions to get the normal vector. And the way that you do that is it is equal to, or I won't say, bad notation, sorry. N of t is equal to plus or minus, and then the exact same thing, except you switch these two, and then you make one of them negative. And the reason that's true is because if you take the dot product of these two, because you switched them, you'll get the same number twice, but you made one of them negative, so they'll end up canceling out. And so you could try that. These two numbers are just scalars. So t dot n is going to be some constant, or sorry, not constant, but some scalar times, and I take the dot product of the vectors, that's t squared minus t squared, which is indeed 0. Okay? And so this vector I found was one of these two purple vectors that I drew earlier. So now this plus or minus out in front is just going to make sure that we get the vector that points inward. And so to figure out whether it should be plus or minus, we have to look at these vectors. We want the one that points inward, so we have to ask ourselves, is the x and y component of this vector positive or negative? And since it points left and up, the x component is negative and the y component is positive. Okay? Negative, positive. So look back at this equation. If we choose plus, so I'll ignore this for a second, we're choosing plus. Here, t squared is positive and negative 1 is negative. And so we have a positive and a negative, which is not what we want. We want a negative and a positive. And so we have to choose the minus. Okay? So that's a shortcut you can do to compute this. That's our normal vector for t greater than 0. The issue, at t equals 0, over here you were pointing down, 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 because you're pointing inward. But up here, you're pointing up, up, up. And so right between these two, at when t equals 0, the normal vector switches from pointing down to pointing up. So the normal vector actually does not exist when t is 0. Okay. If we want, I'm actually going to go ahead and prove this without doing the shortcut. But you don't really have to see that if you don't want to. It's just sort of ugly. To do that, and I'm going to skip through it I'm going to speed through it since this is sort of optional. If you have questions about it, feel free to ask me later. We're going to do the product rule again. So first, times derivative of the seconds, that's 0, 2t, plus second times derivative of the first. The derivative of this is negative 1/2 times 1 over square root of 1 plus t to the 4th cubed times 4t cubed. So that's just the power rule on this square root and then chain rule. And then 1t squared. Okay. And so let's compute what that is. This will be the first component. I'm going to add this 0, this 1, and so I just get negative 1/2 times 4t cubed over square root of 1 plus t to the 4th cubed. And then the second one is 2t over square root of 1 plus t to the 4th minus 2t to the 5th over square root of 1 plus t to the 4th cubed. Okay, I'm going to combine these two, get a common denominator. I'm going to multiply these two, so that'll be negative 2t cubed over the square root of 1 plus t to the 4th cubed. And then here this will be 2t times 1 plus t to the 4th minus 2t to the 5th over the square root of 1 plus t to the 4th cubed. Here the common denominator, I just multiply the top and bottom by 1 plus t to the 4th. Okay? And now this actually does simplify. This 2t times t to the 4th cancels out with this number. And so you end up getting negative 2t cubed over square root of 1 plus t to the 4th cubed, comma, and this just turns into 2t over square root of 1 plus t to the 4th cubed. Okay? And then I'm going to go ahead and factor out 2t over square root of 1 plus t to the 4th cubed, because that's in both of these terms. So then that'll be negative 2t squared, comma 1. And you can sort of see where, oh, sorry, I don't know, negative t squared, comma 1. Not negative 1. Okay, I factored things out wrong the first time. And anyway, you can sort of see where this from up here, t squared negative 1, you can see where that's going to come from. We have a t squared and a 1 here. And then the minus sign is out here. Here we have it inside, but it's basically the same. Okay, so now the length of t prime of t is going to be, again, we have a scalar out in front. So you can just factor that out. And then here, it'll be square root of this first number squared, which is t to the 4th, plus the second number squared, which is 1. Okay? And so then n, I'm not going to simplify this because that's in both of these. They'll cancel out nicely in a second. T prime of t divided by the length of t prime of t. And this one over here, this was t prime of t. And this is length of t prime of t. So that will be 2t over square root 1 plus t to the 4th cubed times negative t squared, comma 1 divided by 2t over the square root of 1 plus t to the 4th cubed times the square root of t to the 4th plus 1. And so now this is nice because these two prefactors cancel out, and we just end up getting 1 over square root t to the 4th plus 1 negative t squared, comma 1. Okay. So that's that. And we do get the same thing as what we got up here. It's just, again, up here, this negative sign here is factored out, but here it's distributed in. So they are the same, just a little bit different. And now you may be asking yourself, it looks like this should work when t is 0. If I plug in t is 0, I get, what? Not t. N of 0 is equal to 0, comma 1. Right? That's what I get, right? So why doesn't this work? Well, the reason is right here, when we did this cancellation, this red step here, we had a t in the numerator and the denominator. What would happen if t were 0? Let's plug that in. If t is 0, this would be 0 over 1 times 0, 1, divided by 0 over 1 times 1, which is equal to 0, comma 0 over 0, which does not exist. Or if you want, it's equal to 0 over 0 times 0, comma 1. And so we can't actually cancel these two out when t is 0 because 0 over 0 is undefined. It's an indeterminate form, even. So we can't even find the limit. And so that's why the normal vector doesn't exist at 0. It's because this step, this red cancellation, was actually invalid if t is equal to 0. You don't really need to know that for a quiz or exam, though. Again, that's more complicated than anything we would ask you. Okay, and then the last one, number 4. This one isn't too ugly. Take a screenshot, and then I'll add a new page because we're running out of room. Okay. Before doing any computations, where do you think that the curvature of the parabola y equals x squared is the greatest? I'm going to go ahead and draw this real quick. Here is our parabola. Pretty nice. And so let's look at this. I'm going to divvy this up into some sections on our curve. And let's draw the tangent vector at each of these. Right here at this top left one, the tangent vector is pointing pretty far down, a little bit to the right. At this next one, it's still pointing down, just a little bit further to the right. At this next one, pointing about at a 45-degree angle down to the right. At this next one, it's still pointing down to the right, but it's almost flat. At this next one, it switches to basically 45 degrees up and to the right. And then similar for these last two. Okay. So these are the tangent vectors. And remember, the curvature is proportional to the length of the tangent, the change in the length of the tangent vector. At which of these does the tangent vector change? Between which of these does the tangent vector change the most? I would say it's between this one and this one. So the point with the maximum curvature is somewhere within this region. And just because there's this really cute point here at the origin, which is, sort of this symmetry point for a parabola, I'm going to say that it's at the origin. So I'm going to put this over here. Max kappa at 0, 0. That's what my guess is. So let's verify that. One problem we see here is they didn't give us a parametrization. So we need to find our own parametrization. Because remember, our first step, we always need to start by finding r prime of t. And we can't do that if we don't have r of t. So let's think of a parametrization. This actually gives us an example for the online parametrization studio. Y equals x squared. Okay? For this one, remember I gave two options for a parametrization. There's sort of a geometric parametrization and what I called an obvious parametrization. So the obvious parametrization is always nice to try first, and that one is x is equal to t, and then I'll just plug in t for x, and I'll get y equals t squared. This is a pretty good parametrization because there's no plus or minuses, there's no division by 0, there's no nothing bad. So yes, we can use this. So we'll have r of t is equal to 2t and t squared. Okay. So now we can try to compute the curvature. This time I'm going to use my formula where kappa is equal to the length of r prime cross r double prime divided by the length of r prime cubed, because I don't have any, I don't have to compute the tangent or normal vector in this question, and this formula is quicker if you don't have to compute either of those two. Okay, so now we just need to find r prime of t, which is 1 comma 2t, and r double prime of t, which is 0 comma 2. Okay, so now we need to find their cross product. Let's meet I, j, k, 1, 2t, 0, 2. And since there's no z component, we can just assume it's 0. Okay, I'm going to do cofactor expansion on this column. So it'll give me k hat times the determinant of 1, 0, 2t, and 2. And since this is a upper triangular matrix, the determinant is just the product of the diagonals. So that's 2k hat. Okay. But remember, our curvature up here, we needed the length of that vector. So the length of r cross, oh sorry, not r, r prime cross r double prime, that is equal to the length of 0, 0, 2, which is just 2. Okay. So now we also need the length of r prime. So r prime is 1 comma 2t, so the length of that is the square root of 1 plus 2t squared is 4t squared. I should I'll write this out a bit more carefully. 1 squared plus 2t squared, which is the square root of 1 plus 4t squared. Be careful to distribute this power of 2 into everything. Okay, and so now I'll just plug this into my formula. The curvature is equal to this derivative, this length up here was just equal to 2 divided by this length here cubed. So it's going to be 1 plus 4t squared cubed. That's our final answer. Okay, so the moral of the story for this question is we want to use this formula whenever we don't have to find the tangent normal vectors. And so now we do need to find where this is maximized. So there's two ways to do this. The first way is with this regular like calculus way. We can find the derivative. That's not a kappa, that's a k. We can find the derivative of the curvature and set that equal to 0 to find relative minima and maximum. But that's a really annoying way to do that. And there's a better way that I prefer. We sort of know the answer is going to be 0. So the curvature at 0 is going to be 2 divided by the square root of 1 plus 0 cubed, so that's just 2. Okay? Let's say I have any number that's not 0. If I have a number that's not 0, this number will be bigger. Because down here it was 0. Here it's going to be something positive. Because t squared, even if t is negative, t squared is positive. Okay? So this number is positive, which means this number is positive, which means this whole denominator is positive. So we know that the curvature at not 0 is equal to 2 divided by a positive number. And actually that positive number is going to be greater than 1. Because the square root of 1 plus a positive number cubed, well, 1 plus a positive number cubed is going to be greater than 1. And so the square root of that's also going to be greater than 1. And so this is actually going to be less than 2. Because let's say I have 2 divided by 1.001 or something. That's going to be like what? 1 point, I don't know. 998 or something like that. It's just an approximation. So it's always going to be less than 2. And so because of that, we know that the maximum occurs at 0. You could, again, do that with single variable calculus, but we're going to do that later in this course, and I don't think it's very illustrative to do that right now. And I wouldn't bother if you don't understand this. It's okay. All right. So that's that problem. That's everything. Most of this worksheet is stuff you wouldn't need to do on an exam. I would say this one is the only one that you would maybe come close to having to do on an exam, but the other ones are just too much. Maybe you could have to find the curvature here, but you wouldn't have to do this stuff down here with finding the maximum value of the curvature. That's a bit too much also. And then 1 and 3 are just super ugly. Okay, so that's that. Hope this was helpful. If you have any questions, feel free to email me, come to my office hours. I was going to say come to my house, but don't do that. Definitely don't do that. And that is it.